Crop circles began to appear in large numbers beginning in the late 1700s, but the earliest are said to date back even into the 1600s. These crop circles have been greeted with much superstition and have been attributed to the works of extraterrestrial life or even to Satan. Serious enthusiasts call themselves Curiologists after Crius. She is the Roman goddess of agriculture and is pictured here. Further enthusiasm has been sparked by the attention that crop circles have gotten in modern media. This includes being the star in movies such as Signs and being in commercial advertising, like in these ads for shredded wheat, for Hello Kitty, and this giant foot designed for a Nike commercial. The attention that they get creates much interest so that more and more crop circles appear year after year. While such superstitions abound, the truth is that 2 to 4 people can make a rather large crop circle using just boards and rope in just a few hours. The question that we are looking at now is what in the world, or out of it, do crop circles have to do with mathematics? Much in every way. Let us look at several examples of proofs that when combined allow us to create a crop circle. Theorem 1 focuses on 3 circles that share a common tangent to make an equilateral triangle. We then circumscribe that triangle, and this provides the foundation for our crop circle. Focusing on the equilateral triangle from the previous theorem and the circumscribed circle going around the triangle, we notice that comparing the area of that circle to the area of the yellow circle that is inscribed inside of the triangle is 4 to 1. We get a similar idea when we look at a square and the areas of a circumscribed circle around the square and an inscribed circle inside the square. But the ratios are a little different, being 2 to the power of m and 1. Our fourth and final theorem carries the same idea, but is looking at a hexagon. Here, our ratios are 4 to 3. Now watch as we take these theorems and the shapes that we learned about and start to pile them one on top of the other. Although the hexagon is not here, if you notice the outermost circle and the second outermost circle, those are the ones from the previous picture. Now we are looking at the square that is inside of those. Here is a combined look at these last 2 pictures. Now we take our inscribed circle, the one that is inside the square, and we place our triangle inside of it, noting the ratio of 4 to 1 with the yellow circle in the very center of our picture. If you have noticed, our theorems have been working backwards. Here we are looking at theorem 1. We have added 3 concentric circles to our pictures and the triangle that touches the center of each circle. Here is where the creators of our crop circles get to be a little creative. They have taken the foundations of the theorems we have looked at, they have combined the pictures, and now they get to add their own artistic flair to create a crop circle of their liking. Here's a picture of a crop circle using the theorems that we have looked at. As you can tell, I have overlaid a picture to help make it a little more obvious of the patterns that are being used. It's a little hard to tell, but a unique feature of this crop circle is that the circles on the outside of the crop circle are actually touching every other point on our hexagon. I hope our little investigation into crop circles has been informative for you, and that you continue to seek for the truth that lies behind such beautiful artistry that can be found not only in man-made crop circles but also in all creation.